Welcome to a quick review on how to graph 9 basic functions. We'll be graphing the 9 functions given here below. And with practice, we should be able to recognize the graph and the equations of these 9 basic functions. Remember, when graphing, if we're not sure what the function looks like, we can always go back to making a table of values. And notice all of the functions will be given using function notation as well as replacing f of x with y. So first we have the constant function f of x equals c, where c is any real number, or again if we want, y equals c. As an example, let's graph y equals 2. This would be a horizontal line through y equals 2 on the y-axis. So it would look something like this. But again, if we weren't sure, we can always make a table of values. Notice how we can select any x value that we want, for example, -1, 0, and 1. But regardless of x, notice y must be 2. So -1, 2 would be here, 0, 2 is here, and 1, 2 is here, giving us our horizontal line. Next we have the identity function, where f of x equals x, or again if we want y equals x, we should recognize this as a line in slope-to-intercept form, where m is the slope and b is the y-intercept. So for y equals x, we'd have y equals 1x plus 0. So the y-intercept would be 0. The slope would be positive 1, or if we want 1 over 1. So from this point, we go up 1, right 1, up 1, right 1, and we have our line, or the identity function. Or again, if we need to, we can use a table of values, -1, 0, and 1 for x. And since y equals x, the x and y coordinates would be the same. -1, -1 is here, 0, 0 is here, and 1, 1 is here, giving us our line. For the absolute value function, we have f of x equals the absolute value of x, or y equals the absolute value of x. This resembles the identity function, except now all the y coordinates will be positive. So if we use the same inputs, or x values, the only difference here is that when x is -1, y will be positive 1, 0, and then 1. So if we plot these 3 points, -1, 1, 0, 0, 1, 1, we have the absolute value function, which we can see has a V shape. Next, we have the quadratic function, or f of x equals x squared. To complete our table, let's use y equals x squared. Let's go ahead and use -2, 0, and 2. So if y equals x squared, -2 squared is positive 4. 0 squared is 0, 2 squared is 4. Let's go ahead and select one more value. Let's select x equals 1. 1 squared is 1. So -2, 4 is here. 0, 0, 2, 4, and 1, 1. This would give us a U-shaped parabola that looks like this. Of course, if we need to, we can always find additional points. Next, we have f of x equals x cubed, or the cubic function, y equals x cubed. So let's use -1, 0, and 1. -1 cubed is -1, 0 cubed is 0, 1 cubed is 1. So the function passes through this point, and this point. But we should recognize that because it's cubic, it will curve. Notice if x was positive 2, 2 cubed would be 8. The next point would be off the screen, but our graph would look something like this. Next we have the square root function, where f of x equals the square root of x. So using y equals the square root of x, let's complete a table of values. Notice here we cannot select x values that are less than 0, otherwise we'd have an imaginary number. So let's go ahead and select 0, 1, and 4. Notice how 4 is convenient because the square root of 4 is equal to 2. So we'd have 0, 1, and 2. So 0, 0, 1, 1, 4, 2. And we have the basic square root function like this. And now we'll look at 3 more. Next we have the cube root function. F of x equals the cube root of x. Or using y equals the cube root of x. Notice here x can be any real number. let's go ahead and select x equals -1, 0, and 1. The cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. So we have -1, -1, 0, 0, and 1, 1. The next perfect cube would be 8. Notice if x is equal to 8, y would be +2, which we can't plot, but it would give us a curve that looks something like this. Next we have the reciprocal function, or f of x equals 1 divided by x. Again, we'll use y equals 1 divided by x. Notice x cannot be 0. Let's select x equals 1 and then x equals 2. If x is 1, we'd have 1 divided by 1, or 1. X is 2, we have y equals 1/2. So we have the point 1, 1 here, the point 2, 1/2 here. And because when x equals 0, we have division by 0, we actually have a vertical asymptote here. So the graph is going to approach the vertical asymptote. It will also approach the x-axis, since as x increases, y approaches 0. So this piece would look like this. We'll have another piece on the other side of the vertical asymptote. So if we select -1 and -2, we'd have -1 and -1/2 for y. So we'd have this point here and this point here. As x approaches -infinity, y approaches 0 again. So the second piece would approach the x-axis going to the left, and it approaches the y-axis going downward. And then finally we have the reciprocal squared function, or f of x equals 1 divided by x squared. So we'll use y equals 1 divided by x squared. Again, notice how x cannot equal 0, so we'll have a vertical asymptote here. So if we select x equals 1 and 2 again, when x is 1, we have 1 divided by 1 squared, or 1. But when x is 2, we have 1 divided by 4, or 1/4. Notice to the right of the vertical asymptote, this function decreases faster. So we have the point 1, 1 here and the point 2, 1/4 here. This piece looks like this. Notice when x is less than 0 or negative, y values will still be positive since we have x squared. So when x is -1, we'd have 1 divided by -1 squared, that's still 1. And then when x is -2, we'd have 1 divided by -2 squared, or 1/4. Again, notice how the y values are always positive here. So when x is less than 0, the graph would pass through this point here and this point here. So the piece on the left looks like this. So there's a quick review of 9 basic functions. And again, with practice, we should be able to recognize the graphs and the equations of these functions. I hope you found this review helpful.